Hey guys, and welcome to Functional Print Friday, and welcome back to my shop. A couple of weeks ago we made a tension wrench for this saw. This wrench actually turns the tension knob over there on the end of the saw, and it's working out really well for that. And yes, I'm aware I haven't shown you guys how I made the design on this wrench yet. It was done with a laser. A couple of you guessed it was the X-Tool F1 Ultra. It was actually not that machine. It's a different laser. It's a MOPA laser. I'm excited to show it to you guys, but still not quite ready yet. I'm working through some issues with the vendor, and I just want to make sure they got all straightened out before I actually do show you guys. However, X-Tool has also reached out and has also sent one of those F1 Ultra machines. So we're actually going to be taking a look at 2 fiber lasers in the next coming months, but that's not what we're here to talk about today. I've got another problem with this bandsaw. Let me show you. So since the last time you guys saw this saw, I have added this rolling base to it. The idea is to be able to just move this thing around the shop wherever I need it. I don't really have a place for it to live, and I figured it's nice to be able to roll it outside as well for cutting larger pieces of stock. And this actually stands up as well to use as a vertical metal cutting bandsaw. And that's where I discovered the problem that we need to solve today. Let me stand it up. So if you just grab this handle and you lift up on the saw, it rests in this vertical position, and then there's actually a table that you can mount here. I mean, you could use it just with this little tiny piece here if you were cutting something small, but there's a whole table that mounts on here. But before I even got that far, I realized that this was not going to work like this. If we walk around the saw, you can probably guess the problem. Now, I do want to point out the base that I put on this machine actually came with 2 axles and 4 wheels. I didn't really like that setup because there's no way to keep it from rolling around. Like the wheels don't have any locks. It's just got 4 wheels on either end. So you can't really steer it. Like it only wants to go in a straight line, and you can't stop it from rolling. The reason I'm mentioning that is because the hole for the axle to go through is a little bit further over. It's right there in line with my finger, and you can see the axle for this one is over here. So I don't know, maybe 1.5 inches. So the wheel that I have on here is about 1.5 inches further this way than at the end. The reason I'm mentioning that is because, can you guess what the problem is here? All the weight on this saw is over here now. The bow of the saw is standing up vertically, and we have this huge gearbox and motor. So if I grab a hold of this handle up here at the top, this whole thing tips up very easily. Now, I'm not just going to ask you to take my word for it. I think we can actually measure that. Let me get you back in the tripod. I got an idea. All right, so if we wrap these zip ties around our knob, pop this guy here, we should actually be able to measure how much force it takes for this to tip back towards me. And you can see it is not much at all, like right around, it's not even 10 pounds. It's less than 10 pounds. Call it between 9 and 10 pounds to tip this guy this direction. And we have to push the work into the saw this way. The teeth on the blade are on that direction. And the center of gravity is going to be even more this direction when we bolt the table on. So I just don't see how you could use it that way. Now, as I mentioned, my wheels, the axle is a little bit further that way, but not by that much. I mean, I can't imagine it would make a difference of maybe 5 pounds here. So I just don't see how you could safely use this saw when it's flipped up vertical like this. I think we just basically need to figure out a way to get more weight on that end. Okay, so if we walk around the back of the saw, and by the way, it might not have been clear from that video, but it's not that this bow here is tipping that direction. The entire saw is lifting up. This end of the saw is actually lifting up off the ground. So what I'm suggesting is that we need to get more weight into this end of the saw. And I put a light down here so you guys can see, because the challenge is there's just not a lot of room to work with there. I mean, my initial thought was, you know, just stacking up some bricks or blocks or something, but it's such an unusual space because we have the shelf here. We've got a little bit of room. This is the coolant tank for this saw, and I can't slide it over any further. It's retained by like a piece of sheet metal down here. It's actually, yeah, you can see it over here on the side. So it slides over into that. And then these triangular pieces down here on the bottom, that's actually the inside of these feet. So there's essentially, it's open on this side, and we have this L that comes over. So we either need to like attach weight to this part of the frame, or the weight needs to somehow rest on this lip. And because it's such a weird shaped area, what I'm thinking about is, what if we just designed some sort of container that maximized the space over here so it fit over into this area and maybe sat on this as well, like up over this lip. These are lower. That face down there on the roller wheels is lower than this, but none of that should be a problem. I mean, we can design around all that, but design a container that maximizes the volume of this area and then fill it with concrete and pop it in there. I think it might work. I've never actually tried to do any like concrete filled prints, but I think that's going to be the best way that we can maximize the space over here with some sort of weight. So I think the next step is to get a bunch of measurements over here, and then I'll probably kind of draw up the rough shape of this, because it's a complicated enough space that I think it's going to be tough to try and just design the container without having a design of the constraints, because we've got a number of things going on in here. We also have, there's like a sort of a little electrical box up here for the switch for the coolant pump. So we've got to work around that. There's some bolts down here at the bottom. We'll have to work around those. So I'm not going to try and film any of the measurements. It's going to be really tight working over here. So I'll get those measurements, I'll start drawing, and I'll bring you guys back. All right, and here is the design that I've got for this so far. And this is very much just a draft design to kind of see if everything is going to fit. And it's a bit confusing to look at because you're seeing both the draft design and sort of the parts of the saw cabinet that I drew just to get an idea of how things are going to fit. So if I hide this, here's just sort of the parts of that saw cabinet, the inside of the cabinet that matter for this design. So like I didn't draw the whole thing or even the whole length of this shelf. This is that shelf that the little coolant tank sits on, because we need to know the position of this lip here from the shelf, the height of this part of the shelf relative to the lower parts down here that are part of that rolling base. That's what these two triangles are, and how both of those are relative to the height of our electrical control box and the height of this overall section. So also not drawn here is the top part, sort of the coolant tray that sits directly underneath the saw that's all the way across the top here. So if I bring that back, you can see this basically just fits into that space. I have a cutout here with an angle so that it prints without supports for the electrical box. And the electrical box doesn't actually come out quite this far. I tried to allow enough room here just with our block for where those cords exit with the glands in the back as well. So I'm going to stop here. It's tempting to keep going, but I really want to print this out and just see if it is actually going to fit into this space, because we have a lot of different things that we're kind of counting on to line up here. We have this width here relative to both the end faces. We have a gap here. If I hide this, it's probably a little bit easier to see. There's actually a slit all the way down through here, the bottom, for it to fit over that lip, so that we have the weight bearing both on the rolling part of the base as well as down here. And when this thing tips up, I mean, all of the weight is going to bear down here on this face, because essentially the saw could still tip in the stand, but by having the weight bear down on this face and on this lip up here, it's still, as soon as it starts to lift out of the base, like the moment it starts to lift out of the base, all the weight's going to be carried on the saw frame anyway, which is where we want it. And these are clearance for, the reason there's a cutout here is that's clearance for those bolts that just attach that lower shelf to the side frame of the saw. So, all right, this is a pretty big print. I imagine even in really draft quality, this thing is going to take quite a while to print. I think I'm just going to print it with one wall. I don't know if that's a good idea or not, particularly for something this big. I guess I'll kind of have to keep a close eye on it. If it starts to go wonky, I'll stop it. But yeah, all right, I'm going to try and print this out, and I will bring you guys back. All right, I was so frustrated with how this thing came out. I didn't even start the camera in my initial test fit here. I'm not sure what I expected. It's totally my fault. Well, it's partly my fault, at least. I mean, I printed this with one wall just so it got done quickly. And not a whole lot of top and bottom layers either. You can see how bad the surface finish is down there in the bottom, but the real problem is it just breaks apart. It has no strength whatsoever. It turns out though that actually kind of worked in my favor because I made a number of mistakes in the initial draft design on this, and I had to keep breaking sections of it off until I got it to fit in there. You can see like this all was initially on top of this print, like this, or in some order that's stacked up here. The big mistake I made was I didn't consider enough space for that electrical box back there. I didn't think about having to angle the box in and lift it up over this lip to actually get it in place. So it was interfering with that box, and I was already way too tight to it. I didn't leave enough clearance. Even without this, I did not leave enough clearance. So I knocked the height of the box all the way down to this just to see if the base of it actually fits. All right, we gotta move our cord out of the way. But if we get our cord out of the way, there we go. It does drop in. And that was the part that I was most worried about, was getting the height of the bottom part here, the position of the lip and the height of the lip lined up with the lower level that the triangles are formed at for these roller legs on the side. And all that fits really well. It is, if I push down on that side of the box, I'm definitely actually pushing on the triangles that shoot over on these guys, and it is sitting flush down here as well. So I think the hardest part is done. I was just way off on the clearance that I needed for that electrical box in the back, and the overall height was just too tall. Even without that, it still wouldn't have fit in here, because this guy has to come in at, like, not only does it have to come in at an angle, and you can see even as much as I knocked off here, we're still like pretty much right at that electrical box to clear, but it also has to go up to clear this lip. So I think the next step is to kind of go back to the drawing board on this. We definitely need far more clearance over there for that electrical box, and this guy's nowhere near sturdy enough. I mean, yeah, I know I did one wall on this. If we increase this to 2 or 3 walls, it would probably be a lot stronger, but I think I just need to go a little bit thicker. I generally do 3mm thickness on my walls for, you know, just prints in general, but this guy is so big, I think we need to go bigger. I think we need to go to maybe 4mm. Remember, I want to maximize the space. It'd be easy to say, oh, well, let's go to 5 or 7. And yeah, it's going to be plenty strong, but we are losing a fair amount of volume then inside the box. So I'm going to go to 4. I'll do probably 3 walls on the print, and we also need better bracing on the inside. I mean, we've lost the top of this brace anyway. This was actually connected at the top before I had to break this apart. But there's not enough bracing. We need probably a brace running in this direction as well. And I don't know why I did this as like a square with a triangle at the top. It probably makes sense to do those as circles instead. So, all right, I'm gonna go work on those changes and I will bring you guys back. All right, and here is our updated design, and I made quite a few changes. I did increase just the overall thickness of all of our walls to 4mm. I rounded all the corners just so that they are significantly stronger, and I added much more bracing on the inside, and I did go ahead and just put like a bunch of, these are 60mm wide holes all the way through here, so that hopefully when we put the concrete in here, we end up with, you know, a level surface of concrete all the way across, and that it is also locked into this box, because I can imagine over time just bumping around the concrete separating from this and, you know, potentially being able to slip out. I guess, you know, gravity's going to keep it in place anyway, but it's certainly not going to come out with all these holes in here. It's going to be locked into position. And the cross bracing here should keep this guy from bowing. You know, without this cross bracing, I can only assume that when we filled this with concrete, the distance between this face and this face would spread out. And likewise, the distance between this face and this face would spread out. If this one spreads from this one over here, that's probably not the end of the world. You know, it might look a little goofy, but it would still fit. If this face spreads further away from this face, or really this face down here, I guess. This is just clearance for that electrical box. It's not going to fit, right? Because this face and this face need to squeeze through that gap in the cabinet. And I think I allowed for about 5mm total of play, maybe even a little bit less. So I guess if it moves a little bit, we're okay, but if it moves any more than that, we're never going to get this into position. And if you recall from the previous one, I had done a cutout just at the top for that electrical box, not realizing how high this part would be when we are tipped sort of back to get it into position, and then also to clear that lip. So I gave myself as much clearance as I think I needed, and then I added, I think, 10 millimeters to it, just so that I don't end up reprinting this thing because it just barely fits. I think our draft one took about 24 hours to print. I can only imagine this one's going to take quite a bit longer because I'm going to do 3 walls, and there's also just a lot more material here. I'll do thicker top and bottom surfaces. All of our actual walls are a whole millimeter thicker. So yeah, this is probably going to be like a 2-day print, which is honestly cutting it pretty close. So I better stop talking and start printing. All right, 41 hours later and it is done. And it honestly looks pretty good, particularly for a print of this big. I did notice it is warped quite a bit here. It looks like it must have pulled up from the supports. This would have been the part down on the bed, and it actually looks pretty square. Let me grab a ruler. All right, so this edge was actually down on the bed, and it's pretty square. There is maybe 0.5 millimeter of lift on this corner. This was supports underneath of it, and yeah, it looks like the adhesion on the support interface just wasn't as good, or yeah, maybe it just pulled the supports up off the bed. I'm not sure. I don't think that's going to matter, and we're not going to see that either. It's really just a question of whether the overall shape does fit, particularly if we picked up enough clearance up here. So, all right, let's go try it. All right, I really hope this fits because it is early Friday afternoon at this point. This guy just came off the bed no more than 10 minutes ago. So if it doesn't fit, there's not time to do another one. Hey, that actually sits in there really nice, even better than our test piece after we broke a bunch of the top parts off so it cleared. I had more of a gap on this side. I knew this piece on the bottom might be a little bit warped and we might have to shim this. But this actually sits on there flatter than our test one did. And if you look at the line here, that would be basically controlled by how even we are sitting on this surface versus the triangles underneath these side pieces, because it's open underneath here. And we're really close because that gap is pretty consistent all the way down. And probably get the camera up there so you guys can see. It looks like we're well clear of the wires in that control panel. Let me pull the camera out, give you guys a look. Oh yeah, I've actually got a much better view on the phone screen here than trying to lean my head down there. So we're well clear of that box. It looks like we're not pulled tight on that wire. And yeah, I think we have really just the right amount of clearance. We probably could have gone maybe 3/4 of an inch taller with this, because remember, this has to angle a little bit sideways as well as lift up to get in, because we have to clear that lip that it actually sits down on. So yeah, I'm pretty happy with that. It'd be really interesting to see how much this weighs after we fill it with concrete. All right, let me get this back out of here. All right, well, I would be lying if I didn't tell you I was nervous about this next step, because what we've got to do next is actually fill this guy up with concrete. Now, I think it's plenty strong enough. Particularly with this internal bracing we added, I'm not worried about this bowing out under the weight of the concrete as we pour it in here. However, concrete is exothermic when it cures. It actually generates quite a bit of heat in the curing process. So even if you start with a cold bag of concrete and cold water, the concrete still gets pretty warm, actually even hot, while it's curing. So what I'm worried about is if these internal braces do get up to the glass transition temperature of PLA, I could see that this could possibly stretch and elongate on these lengths here. If that happens, this is going to get wider, and if this gets wider, it may no longer fit inside the saw. So I got to think about that. Maybe we could do like a water bath on the outside I know that's not really going to help with our internal bracing, but it might help just a little bit to keep the overall temperature of the concrete down, and will definitely help us on the sides. I mean, there's air in here, so that's going to act as an insulator, but I think still cooling the outside faces of this with cold water as we pour the concrete inside might help. So, all right, I gotta go to my barn, grab the bag of concrete that I have, and get everything set up, and I'll bring you guys back. All right, guys, let me walk you through my very hopeful setup here. So the red tote, we're gonna fill up with water as we go. So as we fill our black container here up with concrete, we're gonna fill the red container up with water to hopefully sort of help cool the concrete on the outer extremities of our box. The random orbital sander, I'm going to try and use to actually vibrate our box as we fill it with concrete to minimize the amount of air bubbles that we have in here. The concrete is the quick setting type, and it's a little hard on the bottom. I think just from sitting around, I think most of it is okay, and I think probably the bottom's okay too. I'm going to break it up as I go. I certainly would not use this if I needed the full PSI strength of this mix, as I think part of it has maybe partially cured. But I mean, we just really need to stay together in our box here. And if it does that, that's good. So, all right, I am going to get some gloves on, start breaking this up and start mixing up a little bit of concrete at a time. And yeah, I guess we'll see how this goes. All right, well, I think it goes without saying that that could have gone a lot better. It probably also could have gone worse. So yeah, I think at this point I'm just going to wait and see what happens. Clearly the concrete is overhydrated, having been submersed in the tank here while I wasn't paying attention to the hose. But Yeah, I think it's probably still going to set up plenty good enough for this. Again, I wouldn't have even used this concrete mix being partially sort of lumpy like that for something that I cared about the strength, but we just want weight out of this. So as long as it does set up, we'll be okay. So, all right, well, I'll bring you back. It's been about, I think 28 minutes since I started mixing it. So it should already be starting to set up. So I'll give it a couple hours, I'll bring you back. Okay, so after I turned the camera off, I did come back and just sort of smooth the top out with an old paintbrush. And it's been about 15 minutes. I went in and made a cup of coffee, came back out to check it, and looks like it's already setting up. So I don't see any distortion yet. We might be okay. I'm gonna go grab the forward-looking infrared and just see what temperature it is. So I came back throughout the curing process over the course of the next couple of hours, and I kept checking this, and this is the hottest that I actually ever saw. Was it reached about 84 degrees, and the temperature of the water was about 65. So there definitely was a significant delta between the two. So, you know, it did warm up, but it didn't get anywhere near the glass transition temperature of the plastic. Would it have if we didn't have it in this water bath? I don't know. But either way, I don't think we got anywhere near the temperature to distort anything inside. All right, it's been about 3 hours since I poured this in here. It looks pretty much dry on the top. Oh yeah, it's hard. Yeah, I can kind of pick little pieces off the top. It's not completely cured, but it's cold. I'd say it's probably about the same temperature as, yeah, it's maybe like slightly warmer than the water. I think that is as cured as it's going to get, you know, without sitting for several days. So, yeah, I'll get you guys in the tripod. I'll try and video getting this out of here because we're going to know pretty quick if this worked or not. What I obviously can't see below the surface of the water. This thing could be just all bulged out and messed up below the water line, and we just can't see it yet. So let me get you in the tripod. I'm going to dump this out, and we'll see what we got. Oh, it is definitely heavy. All right, so far this looks really promising. I don't see anywhere on this that it has warped at all. Everything still looks dead straight. So I am anticipating that this is going to, like even on this surface here, it's still dead straight all the way across. So I think this is gonna fit. It's also leaking a little bit. When I deburred this, I did get a little aggressive at one spot on the bottom that would be tough to show you now. And I think actually I may have made a hole into the infill because I've dried this a couple of times and it still seems to be seeping water. So I'm gonna let this sit for a couple minutes just for anything to drain out of it that wants to drain out. That may have actually done us a favor. If water did in fact get up into the infill, it probably cooled the interior walls as well, and maybe even the walls here where this ties together. But so far, this looks to have held together really well. I also want to see what this thing weighs. See if we can get this up on a scale. I'm hoping for at least 50 pounds. I'll be disappointed if it's less than 50. All right, 52.2. I was kind of hoping for closer to 60, but that was also before I had to knock off this whole section over here and decrease the height. So 52.2, I think that's still pretty good. All right, I don't know if you guys are gonna be able to see anything, but I also figured you would be disappointed if you didn't get to watch me struggle to try and get this now 52-pound thing into there. So let's do it. All right, we're in. Maybe next week I'll 3D print a new wrist. Make sure we didn't pinch any wires. Oh, that all looks good. All right, and that's what it actually looks like in there. You can see we've got plenty of clearance for that box back there, plenty of room for that wire. And you can see the gap that we have between the two. But let's see what actual difference we made in changing the center of gravity of this. All right, so I think we were at about 10 pounds last time to tip the whole thing towards me. Let's see where we're at now. All right, looks like this thing maxes out at something in the 20s. I might have a different style of one of these that goes higher. Let me check. All right, I do actually have another style. This one is not going to be as fun to see the display on, but this one goes to, I think, 50 kilograms. So that should be plenty. Nice thing about this one is it also measures the, it just stays on the peak and then you reset it with that. So I will be able to show you guys. All right, there we go. See, it looks like we are 14 kilograms. Let me do the math on that. Okay, that works out to just under 31 pounds, which is a pretty good improvement. We started off around, I think, 9.5, and we are measuring all the way at the end of this lever arm. I did want to do that because that's really, you know, that's the fair place to measure it since that's where we measured it in the first place. But down here where we're pushing work into the saw blade, it probably started out as, you know, closer to 20-25 pounds of force pushing there to tip this whole thing up. And we're, you know, probably, I don't know, exceeding 70 pounds of force pushing on that saw blade now to actually tip this whole thing up, which I think is probably pretty good. So if you've ever wondered if you could just make a form out of PLA and pour concrete into it for something, yes, you can. And there's probably lots of other applications for this, not just, you know, making custom weights. And I kind of was hoping to get a little bit more out of this. I was a little disappointed to see the 52.2. In my head, I was thinking, we're probably at least 60 pounds, maybe even a little bit more. But I guess I could also stack a little bit more on top of that guy as well. I maybe could have gotten, like I said before, maybe another 3/4 inch out of this and still cleared everything to tip this into place. But I could also put, you know, maybe 2 bricks up there or something if I need to. But I don't think I do. I think that's probably enough weight over here. Well, guys, I'm calling that job done. I am happy with the result that we have here. And yeah, there's probably other ways that we could have done some sort of counterweight over here on the side of the saw, but I can't think of a cleaner way of doing it. I mean, we could have stacked up some household bricks. We could have, you know, put a bucket with some chain or sand or rocks or something down there. But then, you know, particularly if we use like sand or rocks, you know, we'd have a big mess anytime this thing got bumped around. That, once it finishes curing, it's not going anywhere. I mean, it's basically a solid block of material. I guess it's going to be a pain to get out if I ever have to, but we could probably push it out from underneath. Again, this whole section over here is open. That part of it is just sitting down on those triangles of these rolling feet. So if I lifted the whole side up a little bit, we could actually push it up and then push it out this way if I do ever need to get it out. Hey guys, as always, thanks for hanging out in the shop with me for this week's design and build. You know, hopefully this inspires you to go out and solve some problems like this on your own. I can think of lots of other applications for filling, you know, 3D prints with concrete. You know, maybe you just want the base of something to be, you know, a lot heavier, or maybe even more rigid. I would imagine, you know, if you're working with good concrete instead of like the lumpy stuff I started with, that would probably also set up really rigid and strong, so strong that you'd have a hard time duplicating it even with, you know, potentially steel. So let me know down in the comments if this gives you any ideas or if you've done anything similar to this. And if this is by chance your first time here on the channel, this is all we do. It's all functional prints like this. I don't do any like knick-knack of the week or just multicolored garbage. It's all functional stuff like this. So if you're into that, check out some of the other videos on the channel. If you like what you see, hit the subscribe button. And guys, if you do, I'll see you next Friday.